In this video, we will determine whether or not this function is even, odd, or neither, and we're talking about symmetry here. At a glance, we can tell by looking at the exponents. If it is odd, all of the exponents will be odd. If it's even, all of the exponents will be even. If there's a mixture of even and odd, then it is neither. So obviously 7 is odd and 3 is odd. When you just have x, is the exponent a 1 or is it a 0? Hopefully you said 1. Alright, and 1 is odd. So all three of these are odd, so we know the answer is going to be B. Now, when is the exponent going to be 0? Say if instead of negative 4x, I just had negative 4. Alright, just a constant. That's when that would be the same thing as negative 4x to the 0 power, and 0 is actually even. So just that didn't happen this time, but watch out for it. So we know the answer, but sometimes we are asked to prove algebraically whether or not it is even, odd, or neither. I want to show you that as well, so you'll be ready for it. And here's how you do that. You substitute in negative x into the function. If you get back the original function again, it's even. If you substitute negative x in, okay, and you get the opposite function, then it's odd. If it's neither of these, then that's when it's going to be neither. So obviously we have the original function here. Okay, I'll just put a box around that. Let me write the negative function for comparison. Alright, if I had negative 4x to the 7th power, positive 8x to the 3rd power, and positive 4x. This is the negative function. Alright, I just distributed negative 1 through everything. Okay, so let's substitute in negative x and see what happens. Do we get either one of these? So if I do that, then I would have 4 and times negative x to the 7th power minus 8 times negative x to the 3rd power and negative 4 times negative x. Well, if you have an odd power, the negative stays. It's not going anywhere. So I have a positive times a negative is a negative. So negative 4x to the 7th power. Again, odd power, this is going to stay negative. So I have a negative times a negative. That's a positive. So that'll be positive 8x to the 3rd power. Now, I have no power here, so this definitely is not going to go away. A negative times a negative is a positive, so that'll be a positive 4x. So compare what we got after we, so this is our f of negative x. Okay, this blue one. And notice how that matches the negative function. Boom, boom, boom. So that's how we prove that they're odd. So to wrap this up as a proof, we would say since f of negative x, okay, that's this, equals negative f of x, okay, that's this red one, it is odd.